Okay, welcome back, everybody. We're ready to dive into our final set of presentations and discussions for today. So as I mentioned, our first panel is going to be hearing from two representatives of regional governments, and they're going to share their experiences with designing and operating active transportation census programs in their jurisdictions. Then we're going to have one final presentation on emerging data sources. So, so for this first session, we're going to hear from representatives of the Southern California Association of Governments and then the Delaware Valley Regional Planning Commission back east. And then we're going to take some questions at the end. So again, feel free to add your questions into the Q&A box at any time, and we will do our best to answer those either in writing or verbally. So I'd first like to introduce Hina Chanchlani. And Hina, I know you have some slides, so you can go ahead and pull those up and share those if you're ready. Hina is going to talk about the Southern California Association of Governments experience with collecting bicycle and pedestrian data. Hina is an associate regional planner with Skag, which is the Metropolitan Planning Organization for the 6-county region in Southern California, centered around Los Angeles. In her current role, she oversees Skag's active transportation database, which we're going to be hearing about, as well as the multimodal corridor planning program, and she strives to incorporate equitable outcomes for the region through her work. So Hina, thank you so much for joining us, and we're excited to hear what you have to say.
Of course. Hi, everyone. My name is Hina Chanchlani, and I'm an associate regional planner at Southern California Associations of Governments, also known as Skag. I'm very happy to be here today and learn from everyone about their efforts. I have been managing the Skag's active transportation database for a while now, and I help with providing resources to the jurisdictions in our region to collect bike and ped counts. Today, I'll be walking you through our active transportation database, or ATDB, as we call it. And Mike, let me know if you can see my screen. Okay, yes, and hear me okay. Okay, perfect. Okay. So before I talk about ATDB, I'll provide with a brief background on what Skag is and briefly describe its role as it relates to ATDB. The Southern California Associations of Governments, also known as Skag, is the nation's largest regional planning agency, and it covers a region that spans 6 counties, 191 cities, and 19.1 million residents. Skag is responsible for conducting land use and transportation planning as a part of the Regional Transportation Plan and Sustainable Community Strategies, the RTP-SCS. And this requires Skag to collect and analyze data on a variety of transportation topics to meet federal and state mandates related to air quality, safety, and greenhouse gas reductions. So one of the Skag's primary role and responsibility is to function as a regional data and information center for our jurisdictions. The ATDB was developed to encourage collaboration between jurisdictions to provide one central database where each jurisdiction in our region can upload, store, and retrieve active transportation volume count data in a standardized format. So what is the active transportation database, or ATDB as we call it? The ATDB is a place to store bike and pedestrian count volumes. The counts will help us with measuring project success, develop accurate rates of biking and walking, and tell us who is using this infrastructure. This data can also prove useful when analyzing collisions. And as everyone on this panel mentioned the importance of partnerships, the ATDB was developed in collaboration with LA Metropolitan Transportation Authority, also known as LA Metro, and San Bernardino County Transportation Authority, also known as SBCTA. And it expanded upon UCLA's Bicycle Data Clearinghouse by adding pedestrian counts and many more additional features. The work was funded by using a combination of federal, state, and local money. And so moving on to the next slide, I'll briefly go over Skag's role and goals for the ATDB. Skag's role in this process was to plan for the database development so that we could support our jurisdictions, as mentioned earlier, with the resources they need. The database has been active since March 2019, and since Skag has provided multiple trainings and technical assistance for our cities and several other jurisdictions. As we add more data, there is potential to use the data for modeling and forecasting purposes. The original goal, though, to develop a database like this was to provide a standardized count methodology for our region and to also allow flexibility for jurisdictions to use the methodology as it suits their local contexts and needs. The ATDB enables agencies to store and collect manual data as well as automated count data. And having this information will support cities as they plan for future projects, identify how local streets can be improved, and measure the impacts of transportation of infrastructure projects. This database serves as one-stop shop for active transportation counts and other data. And lastly, there is open data that can be used by researchers to conduct their research. So now let's quickly dive into the database. I wish I could have like a visual see-through for the database, but I don't have that at this point. So let's see how this operates using some screenshots. There are three main components on this database: an upload interface, a data storage and maintenance interface, and a mapping and public access interface. Okay, so this is an example of how the upload, data storage, and maintenance interface looks like when you register for an account and create a count study. The left one is a manual form to conduct bike and ped counts, the left picture, and then there are a few other pictures to describe how the interface looks like. There's also an example of how the mapping and public access looks like on the bottom. And for this view, you may not need to create or register for an account. This is open data for anyone who wants to access this database. The data will be captured through manual and automated counts. The manual counts will occur on an as-needed basis and will use paper count forms, as we see on the left, as I described earlier, or a mobile application, which is called the Bike Ped Counter app. Automated count data will use a variety of technology to capture ongoing 24-hour, 365 days counts. Counters by EcoVigio are currently built into the system for conducting automated counts. And we could also get some additional details like the gender, age, mode, helmet, riding on a sidewalk, and we can integrate this in the Bike Ped Counter app. Okay. So as mentioned earlier, the upload interface does require an agency to register through the website and create an account. This can actually be done by agencies, cities, counties, or even a consultant. The count program will need to be created in the upload interface of the database, and there are 4 steps to developing a count program, and I'll keep this brief as there's a lot to cover. So let us start by understanding what the reasons for counting are. Some of the common reasons may include counts that are required by grant funding, counts to support with traffic studies, counts for long-range planning and modeling, counts collected as part of the community engagement efforts, and some before and after counts for infrastructure projects to determine project progress. The next thing is Skag developed a recommended template to align purpose of the counts, with type of the counts, and can be adjusted based on the need. So for example, if city wants to conduct a traffic study and wants to collect count data, the recommended method for collecting data is using temporary counters that can be installed and registered on the database. The counts can be automatically pulled from the counter to the database and are short duration counts required for the analysis. The ATP grants require count data as part of the application to measure progress of a project or a plan, and in this case, the city can collect manual counts. Determining when to count is an important step, as mentioned by Krista earlier. The comparison for counts should be apples to apples. It is recommended that the count study should be set up in a way that gathers data for either same days of the week, same months of the year, or in the same type of weather. Again, as Krista mentioned, the importance of when to collect and account for variation and develop adjustment factors. It is really important to determine when to count. So again, where to count is part art, part science. Focus on areas of heavy usage to increase the accuracy of the counts, and focus on areas where you think new projects will occur to create a baseline. So now that you know why, when, and where, you need to finalize your decision on how. Think about the available resources and your purpose in determining this. An intersection improvement would likely need intersection counts, a corridor improvement will need corridor counts, and a county-wide counting program will need automated counters. Moving on, currently on the active transportation database, there are nearly 70 registered agencies, including cities, counties, state agencies, CBOs, and consulting firms working on behalf of jurisdictions, and more than 700 locations with available count data. It is expected that as requirements for this count data grow stronger, such as for the active transportation program funded projects, and as more outreach and trainings are conducted to jurisdictions and the community-based organizations throughout the region and the state, the number of users and amount of count data will grow significantly. Data collected in the Atdb is publicly available, allowing planners, researchers, and any interested stakeholders to have access to what has the potential to become the largest source of active transportation count data in the country. Some of the cities in our region who have added counts are on the slide: City of Long Beach, City of LA, Los Angeles, City of Garden Grove, City of Santa Ana, LA County Department of Public Health, and some community advocates like Active SGV and LA County Bicycle Coalition. These cities have also helped Skag a lot with identifying bugs and user errors for Skag to fix. And we also include historical counts from 2015, which were originally a part of the Bicycle Data Clearinghouse, sorry. Moving on, Skag offers a variety of resources to our jurisdictions to develop count programs and to conduct counts. We also have tutorials on our website to help with when and where to count. When we share this presentation, all these bullet points are linked so that you can have access to these tutorials. If you go to Atdb, you can also find these tutorials on the website. And you don't need to register or have an account. You can access these tutorials. Okay, so let's discuss some of the challenges and opportunities with the database, as many of us have talked about this already. One of the challenges for the current database is identifying the accuracy of the data that is being uploaded. Validating data has become one of the most challenging tasks on this system because, like most systems, the database may have glitches or bugs that may crop up due to unknown reasons. One recent example that was brought to our attention is that a city added their data to the database accurately using manual counts method. And instead, the system logging in counts for 12 p.m., which is daytime. The system logged in the counts for 12 a.m. It was a system error because these counts were uploaded manually on the system. There was some kind of bug on the system that did not allow the system to pick counts at 12 p.m. And it picked counts at 12 a.m. So IT staff at Skag had to be brought in to resolve this issue. This becomes challenging when there is time crunch or staff is limited. But now on the flip side, there is an opportunity with GIS-based database to develop an integrated network to collect counts and visually identify locations through this database. Moving forward, automation and big data integration will be very helpful in minimizing staff effort. Moving on, what are some of the lessons learned throughout the process? Skag regularly solicits feedback through emails, calls, training sessions from agencies who utilize the database to identify areas of improvement and understand the usefulness of the database. We always learn something new in the process and try to improve. One thing that Skag has learned is that managing a project like this database requires some basic familiarity with IT terms and databases in general. The process would teach most of it, but there is a need for a dedicated IT team who can support with maintaining the database and performing quick bug fixes. For Skag, the biggest lesson learned is that this is a partnership effort where collaborating with other agencies is the key. As mentioned by many on this call, developing partnerships is extremely important for this process. Lastly, staff turnover has been a challenge, and that is why it is critical for us to document every step of the process. It's been a little over 6 months. I have been managing this database and I'm still learning something new every day, be it a new IT term or any new research as it relates to bike and pet counts. So I'm very happy to be here and learn from everyone who has been in this process of developing active transportation counts. Next steps. In terms of next steps, there, in partnership with Caltrans, the active transportation database will be migrated and the resources will be made available statewide for the state to utilize and the jurisdictions to utilize. The migration will begin sometime in September 2022. Meanwhile, Skag will continue to provide technical assistance and training to jurisdictions who like to access the database and add data. And lastly, I would like to thank all of our current users for their continued count efforts and all the partner agencies who have worked to design and operate this database. For more information, you can always email at atdb.skag.ca.gov, or you could go onto this website and register and look at how the database looks like. And I will pass it on to Mike.
Great. Thank you so much, Hina, for sharing your experiences with all of us. We're now going to move to the other side of the country. We're happy to have Josh Rocks with us, who's the travel monitoring office manager for the Delaware Valley Regional Planning Commission, which is the MPO for the Greater Philadelphia region. And his office manages the pedestrian and bicycle count program for the region. And Josh, I think your MPO has approached this from a little bit of a different angle. So we're happy to have you with us, and go ahead and share your screen if that's working for you.
See if I can do this and then bring screen 2 and then slideshow. All right, is that coming up? Everybody can see that? All right, so just like to say thank you for inviting me here today. It's been really wonderful hearing everybody's different perspectives and how they've done things, and learned a lot of really interesting things today. as Mike said, we've taken a much different approach to our counting program than a lot of others. We've been doing this for over 10 years now. We are the MPO for the greater Philadelphia region, comprising of Delaware, Chester, Montgomery, Bucks, and Philadelphia and PA, and Mercer, Burlington, Camden, and Gloucester counties in New Jersey. We already had an established vehicular counting program for PennDOT, which we modeled our active transportation planning or our counting efforts on. When we decided to do that, we already had a fleet of vehicles and technicians and already had familiarity with many different varieties of counting methods, whether it be ATR with tube, video, radar, and manual counting methods. And so when we decided to go this route, we decided to look for equipment that was going to fit into what we already knew, which is how we kind of settled on using Eco Counter for our systems, because it was just tube on the road for the most part, and we can have any one of our technicians go out there and do that. We've been doing that for over 10 years, starting with pedestrian, moving towards bicycle, and then we eventually were able to secure some grant money, as Liz had mentioned earlier, from the William Penn Foundation to start installing permanent count locations on some of our trails as we built out the trail network in the greater Philadelphia region. We have 17 permanent locations, like it says, primarily in trails, but we just recently put in our 2 in-street installations in Center City, Philadelphia, on 2 very major bike corridors, Spruce Street and Pine Street. These locations help us establish patterns for seasonal correction factors and to calculate annual average daily bicyclists from our temporary count sites. We do have an established cyclical bicycle and pedestrian counting program. Our cyclical bike program is going into, I believe, its 5th year now. So we have 150 locations. We take 50 a year to go through it. So we're coming through our second rotation of counting these particular sites again, and we just started our pedestrian location. Again, we have about 100 locations there. We split them up into sets of 30 to go over a 3-year cycle. Each year we perform over 200 temporary pedestrian and bicycle counts, pedestrian counts in the region. And why do we count these different pedestrians and bicyclists? And as Liz said, again, if you're not counted, you don't count. And so we felt that in order to give walking and bicycling the legitimacy it deserves, that we should start counting it to provide data of usage on these facilities, just like we do for our motorized vehicles. And this also led to feeding into our planning and planning and modeling side of it as well. We have a pedestrian and bicycle planning office, and they needed data to start, backing up their recommendations and to substantiate their findings. We were getting a lot of different types of grants in the region that needed before, during, and after counts for so many years. And so we needed to start taking data for that. And then we were also doing this to help the different municipalities find where they needed to do counting if they wanted to install their own permanent bicyclist counting equipment or do their own pedestrian improvements at intersections or corridors. We could start showing what that data was. One of the big things that we do, it's called our Dvrpc Expo projects, where a municipality can apply for our assistance to help put in a temporary bike lane or a temporary lane configuration. And we will go out for 2 weeks before this is installed, and we take a full suite of bicycle, pedestrian, vehicular, and speed counts along that corridor. We take the same counts while the installation is in, and then we go back after the installation is removed and take the same counts. And we're able to show not always a big increase in biking and walking, as sometimes those changes are very hard to determine and people don't always walk or bike where you want to go. But we have shown that traffic tends to slow down or decrease on some of these roadways. And so we can kind of show through these projects that there is a added safety benefit for everyone by getting everyone to slow down and traffic to drop. So our data is stored in the same database that we use for our vehicular counting, and it's in the same format. Everything is taken in a 15-minute increment. We add it to the same data with the same data, metadata, and that all feeds into our web viewer, where you can see every type of count that we've taken throughout the history of Dvrpc, which is going back 30 years of counting data and about 10 or more years for bicycle and pedestrian data. We kind of consider ourselves the clearinghouse for this data in the region, in that we will take all data that is collected from other agencies, other projects, and for other uses, and we will import that into our database and display it as well, along with everything else. So people only have to go to one place to get all this data. One of the things we found out by using EcoCounter in that regard is that if other agencies are using EcoCounter data, we can get access to their data, which has helped increase the amount of permanent sites that we can get in our region to help us maintain our correction facilities. And we've also used our data hosting abilities to help other agencies with their grant approaches. One of the grants that we worked on was the City of Philadelphia's Health Department was trying to look for health outcomes for disadvantaged or low-income communities. And so we were on their steering committee to help them test out different locations to put permanent pedestrian counters. We went out and installed the counters for them, and then we hosted that on our website for the duration of the grant. And I believe we still do now for them. We've used our data to help inform municipal plans and different bike plans. The City of Philadelphia uses our data in their bike plans and in their configurations for some of their lane changes as they make through to the cities. Some of the counties use our plans and our data to help inform their bike plans for their counties and where they should build out infrastructure. And so it's an important resource that we have that we provide for our region. And so we've undertaken collecting this data and displaying it. One of the biggest impacts where we were able to use this data was during the COVID lockdowns. So since we had access to so many permanent locations that were both in the city and in suburban sections, we were able to kind of track how everything was shutting down, but then notice how people were getting out to use these trails in different ways. Our center city permanent collectors really showed a drop of activity, while our suburban trails data really showed that we had a much higher increase during the week of things, and that a lot of people were out taking advantage of being able to get on a trail. Even using that trail to commute into the city, we saw greater usage of some of these trails that are used as typical corridors to get into the city. So, we were surmising that, health workers and others were not taking the bus, riding in or walking in along these other corridors into the city to get where they needed to go. So that was been really helpful to have that data available, not just to us, but to other agencies that were also tracking this data during COVID. We also took several, temporary counts there. We still had our staff out there collecting data during the shutdown to track behaviors, to track patterns, and just to see what was happening. And that data is all available. And we've summarized that on our website. So we've become the regional expert for bicycle and pedestrian data, and we've been able to provide a lot of guidance to our local municipalities and different member agencies who come to us when they're thinking about either putting in permanent counters, should they be taking permanent counts, can we just take temporary counts for them? And after conversations and taking some temporary counts for people, sometimes we can recommend where they should put their permanent locations. And when we can get access to that data, sometimes we can convince them that we can take a series of temporary counts through the year for you if you're only looking for a few things to count different locations. The problem with that is it is very time consuming and it is expensive. With our 17 counters right now, one of the biggest things that we're fighting with is upgrading the data. As the 3G network is being turned off, we have to replace all the loggers in them. We have several that have broken at the same time, and we're kind of facing a budget crunch just due to inflation and other supplies that, we don't have a specific set of funding for these counters, and we've been kind of stealing it from other projects where we can, and we're getting to the point where that's not enough. And if we want our network to grow, we have to find a specific set of funding from the state or for some other outside location, or even from some projects within our own organizations to be able to fund these things. Otherwise, it's just not going to be able to be maintained. We won't be able to continue to grow. I mean, ideally, we would like to have more in the street, in urban and suburban and other area types, pedestrian and bicycle counters, so we won't have to rely on our trail counters so much. But maintaining 17 trail counters, trying to ask for more money to do more counts is going to be very difficult, especially in the absence of a lot of state guidance in terms of where we should be counting, what we should be counting, how we should be counting, and possibly finding funding for us to do those counts. It's growing, like as we see in other states, Florida's doing a great job. California's going to do a great job, just from what I'm hearing today. Other states are starting to step in and at least provide that guidance to different MPOs on what they can and can't do. So we're waiting for New Jersey to get on the same page as Pennsylvania, being a bi-state agency. So make sure we can have the same set of fundings to do these things, because that's become our biggest limiter in what we do. We take our counts for a variety of reasons. Our temporary counts are there to assist any project that may arise, and that funding is pretty stable. The funding for permanent locations and where should we put these permanent locations and how do we fund these things, that's been our biggest obstacle over the past several years. And that's been one of the newest challenges that we're facing going into the next year. Is now we have a mature set of counters. So we have to go back and replace these counters. As we replace these counters, we're finding we have to revalidate these counters. Technology has changed. Some of the locations aren't good anymore, so we have to find new locations. We have to make sure everybody's on board with these locations. And that's been, difficult as we've, grown and our facilities have matured. The next biggest challenge we faced is incorporating big data with our own organic count data, because we'll have a lot of people who will come to us and be like, well, why should we paying you to take these counts when we can just get this data from Strava, we can just get this data from Streetlight? And, like we like to remind them is that data needs to be validated and calibrated for this particular region, and that you're still going to need these ground truth counts to help you determine how accurate those counts can be, or if they're accurate enough, or to even expand them out further to where they don't have great coverage. And then how do we incorporate that into our database and into everything and make it publicly data? Because sometimes when we're buying a lot of this big data, we can't always make it as publicly available as we would like. And, our mantra here at Dvrpc has been to make all of our data publicly available, which is why we've continued to really invest or push for our own counting program, because if we've taken these counts, we know we can provide this to everybody else. The future is going to be interesting over the next few years as we start to incorporate this data into our plans, as we start to continue to grow our other network, and as we continue to maintain the network that we have. So we've been doing it for the past 10 years. We've done it for a while, and we would like to continue to do it. And it's going to be difficult as we move forward. I probably spoke a little too fast there, Mike. So I'm kind of, I think, done through this one, unfortunately. I mean, I feel like a lot of the stuff I would have said has already been said. Everybody's really touched on all these topics all day today. The same things about validating your data, which is, yes, that was a big struggle for ours. How do we validate our data? Figuring out where we take our counts, that was a huge battle, and we went through several iterations of, do we just let the counties and municipalities decide? Do we come up with a more rigorous scientific method to do that? What equipment do we purchase and how and why? And, it's all been discussed today. So I feel like, this workshop has done a great job of hitting the major issues that Caltrans is probably going to face or is facing as they're setting this up. And you've really pulled in the experts. So, coming last, I feel like it's almost like it's all been said. Like, these are all the same problems we faced with. And I'd like to say we came up with answers, but we're still, as things evolve, coming up with new answers to how we approach these things.
Well, you're further ahead than many, Josh. So that was great. Thank you for sharing your experiences. I think we maybe have time for one question. And Josh, you touched on this. I'm not sure if Hina did, but I'm wondering if both of you could talk a little bit more about kind of funding and support for these programs. Josh, you talked about funding, but Hina, maybe if you have anything to add there, but just whether your organizations are kind of seeing the value in collecting this data, and whether kind of long-term support for these types of data collection programs is available, or kind of how you'd like to work with your state DOT to kind of approve support. So Josh, you touched on elements of that already, but if there's anything you want to add, and then Hina, I'd love to hear from you as well about kind of your experience with Skag.
I can add a few things that since we already had a well-funded counting program from PennDOT for vehicular, at the beginning, it was just an incremental cost of new equipment to go out and do this work. And a lot of it was piggybacking on spots that PennDOT already wanted counted. But now, as we've gotten beyond that, we're looking to either get PennDOT or the counties to fund a whole, active transportation counting program that is separate than just this, vehicular counting program with its own set of permanent funding. And we're working on building that up now and approaching PennDOT and NJDOT to see if they're willing to engage in this and to see how much use there is from them. I mean, internally, we've gotten a lot of support from our internal offices and even our external counties for this effort to do that. And that's where we'd like to go is to have PennDOT to be able to give us whatever they think they can give us, and New Jersey DOT chip in as well. So we can continue to expand our cyclical count program for the whole region and our pedestrian count program for the whole region, but also all the temporary counts as well. And that's, it's starting to go into the work planning program effort, as we go into the next year's work planning program to see if we can get that support.
Great. Hina?
Yeah, and I can touch a little bit about funding on Skags, and we did receive some federal and a combination of federal and local funds initially when we started this process out. Some of our next steps do include migrating this database to Caltrans, which is statewide migration. So that is upcoming, and we already had that funding to migrate this database to Caltrans. So that's on the funding end.
Okay, great. Well, thank you both so much for being on and sharing your experiences. And I think as Caltrans and many of the agencies on this call begin to wrestle with some of the same issues that you both have already wrestled with, those experiences are gonna be really beneficial for others. Okay, well, we've reached our final kind of meaty presentation here before we start wrapping up. We've heard a lot already today from other speakers about emerging data sources, big data. What role can some of these new sources of data like Strava and Streetlight play in a count program for bikes and pedestrians? So we're very happy to introduce Dr. Sirisha Kuturi, who's a senior research associate in the Department of Civil and Environmental Engineering at Portland State University, and she's affiliated with the Transportation Research and Education Center there. And Dr. Kuturi's primary research interests are in the areas of multimodal traffic operations, bike ped counting, and safety. And her team recently published this great study on integrating emerging sources of bicycle data with conventional data to predict kind of these network-wide bicycle volumes. So Sirisha, I know a couple of your team members are also on the call, and if you'd like to go ahead and share your screen and kick us off, that would be wonderful.
Sure. Can you see my screen?
Yes, it's not in presentation mode yet.
Yeah, I'm trying to put. Is it good now?
Looks good, yeah.
Okay, great. Thank you, Mike, for inviting me to talk today about this large-scale project that we had recently completed to derive bicycle volumes on a network using data fusion techniques. Before I move on, I just wanted to take a minute to introduce and acknowledge the contributions of the other team members on this study. As you can imagine, it was a huge project, and we would not have completed it without all their efforts. So we had Joe Broach and Nathan McNeil from Portland State University, Kate Hune, Steve Mattingly, and Mintu Mia from the University of Texas at Arlington, Kristen Nordbach from UNC Chapel Hill, and Frank Prue, who's an independent consultant on this study. Joe and Kate are both here today to help with any Q&A. I think everybody who's spoken today has spoken about the importance of counting, and Darren set it off very well when he spoke about the importance for equity purposes, for building networks, for safety analysis, and for just encouraging people to walk and bike more. Traditionally, our information about bicycling activity has come from travel surveys, which can be either national or regional, or we have gotten information from the observed counts of cyclists, which could be both through automated technologies, as Krista talked about, or through manual methods, which are most often for a limited time at a small set of locations. This information has been used to estimate direct demand or travel demand models, which give us information about bicycling activity, but they're not to the level of detail that we want. So recently we have the emergence of these third-party data sources. You have your opt-in apps like Strava, where the user actually goes in and enters information about their bike trip. You also have apps that run in the background like Streetlight, which collect information about your location and then impute your mode from that location. And then you have your bike sharing apps like Biketown, for example, in Portland, which provides you information about the bike share trips that you've taken. And these recently have been proposed as replacements to the traditional count data sources because they are collected continuously and all over the network. But we still have to understand how representative they are and how useful they can be in predicting bike volumes over the entire network. So all the studies that have been done so far are limited in scope, and they've just looked at one region or have limited comparison to counts. So our study is more robust, and we wanted to conduct a more rigorous evaluation of these third-party data sources for factors such as accuracy, coverage, completeness, and representativeness. We also wanted to understand how we can combine these sources along with conventional data sources, investigate different modeling techniques. So both the traditional count models as well as the advanced machine learning techniques to estimate volume over the entire network. And finally, the overarching important question of what relative marginal value do each of these data sources and model forms add in predicting bicycle volumes. So to achieve these objectives, we wanted to select sites that were geographically dispersed and represented a broad range of contexts. We also wanted to select sites that had a good amount of count data available and at least a few locations that had bike share data available. So we ended up selecting 6 sites. 3 of these cities, Boulder, Charlotte, and Dallas, formed our basic sites where we used 1 year of data, 2019, to develop our models. And the 3 Oregon cities, Bend, Eugene, and Portland, is where we tried to use 3 years of data, if available, to sort of understand the temporal stability of these data sources. So once we had our data selected, we had to undertake a huge effort to sort of assemble all these data sources. And as people who've worked with data before know, this was a huge task and it took a long time and definitely more than what we were expecting. And so this slide here just shows the overview of all the tasks that we undertook to get the data ready for modeling. And I'll talk briefly about each of the data sources that we used. So the count data was our most important, I guess, source or one of the most important sources that we used in the analysis. We had 2 different types of count data that we used, permanent counts and short duration counts. When we started looking at the permanent count data, we noticed that the uptime on some of the counters was actually pretty poor. And so we ended up having to sort of divide our permanent count data into 2 categories, where we had more than 10 months of valid data at each counter. We termed it as a complete permanent count data. And for all the sites that had less than 10 months of count data, we deemed them as incomplete permanent count data and treated them as short duration counts. Additionally, we also used short duration counts that were at least 24 hours or more in length. As Krista and others have pointed out, using counts that are 2 hours or less than that can introduce high amounts of error in the model, and we definitely wanted to avoid that. So here's a distribution of the total count sites that we used in the study. We had 603 across the 3 different years. You can see Boulder, Charlotte, and Dallas had the 1 year of data, as I mentioned previously. In Bend and Eugene, although we wanted to use 3 years of data, we did not have information for 2017. So we just ended up with 2 years of data, 2018 and 2019. And Portland, we had all 3 years of data available. So we gathered the permanent count data as much as possible from standardized archives that we heard about. So the Oregon data, we tried to use Bike Ped Portal. Thanks to Phil, we had the Dallas data from the Texas archive. But there was also, for some other locations, like for example, Boulder, we had to get it from the city directly. So this led to problems with standardization, as you can imagine. The data were all in different formats. And also issues with access. Sometimes the data is available after a long time after it was collected. So we had to, in some cases, wait for the data to be processed and uploaded to the archives. One thing we did not have resources to do, obviously, was to validate this data. We assumed that the data that was given to us was closely representing the ground truth. We, however, did pass the data through our own QA/QC process and then manually reviewed a small amount of flags that were created during the automated cleaning process. Here's a slide that's showing our short-term counters that we used across the 3 years. We had overall 471 counters, and a majority of them were between 1 week to less than 1 month, as is the current recommendation for using short-term counts. These counts were mainly in Bend and Eugene. Bend, for example, has this rotation program where they have some automated counters, and then they rotate them across the network to count, to get these short duration counts. And so, so you're able to count for greater than 1 week at these locations. Portland, on the other hand, used pneumatic tubes or hose counts, and so their counts were smaller in duration, and it was between 24 hours to 72 hours. The Strava data at the time when we did this study was still not free, so we had to purchase it from Strava. And it was delivered to us with the underlying OSM network. We had a couple of issues that we did see while processing this data. One of them is this map matching issue. And on this figure on the left here, there's this permanent bike counter location in green. And so there is a bike facility here, but the Strava counts that we got had them spread out on the parallel links, as you can see. So the numbers in parentheses are the Strava counts that we received from them. And so if you wanted an accurate Strava count at this location, technically you have to add all these counts and then compare that with the permanent counter data. Another issue we did see was where in this case here, there are bike facilities on either side of the bridge here, and you notice the 2 permanent counters on either side. But the Strava data in this case is mapped to a single OSM link. And so we're not able to use the 2 permanent counts that we have at this location. Another issue we did see was this issue of masking where counts less than 3, so 0, 1, or 2, Strava counts are rounded up to 5. And so this can cause some errors at those lower volume locations. Streetlight data is generally available in an index, adjusted index form, but because that in how they calculate that index data is not very transparent, and we wanted to minimize the error, we decided to use the raw streetlight data, and this is generally not available to everyone, but you can definitely ask and get that data. There was also some effort involved in getting these counts out of the database. For each location, we had to go in and manually draw these gates and then get the data out at all the locations where we had our permanent counters on our network. Another data set that we used was the bike share data, and this data was only available at the Oregon locations. It was available in 2 formats. We either had the lat long for all the points on the entire trip, or we had lat longs for just the start and end points in the trip. We drew some buffers for the origin destinations, and then estimated some variables to use this data in the modeling process. And finally, we had our static data, and this included the network and socio-demographic and weather variables. The network variables were all drawn from the OSM just to keep it standard across the different cities. We got the socio-demographic data from NHEIS and the weather data from a standardized website as well. So once we had all our data, the next step was to develop our modeling framework. And we basically specified 3 sets of models. We had all city pooled, where we pooled the data from all the cities into one model. We wanted to look at regional models, so we pooled just the Oregon data into one model. And then we also developed the city-specific models. And as you can see, these were done for the different years and different locations as and when data would permit. Another important categorization that we did was looking at just models with the complete permanent counts. So as others have said, complete permanent counts are our closest measure to ground truth. And so we wanted to develop this set of models to compare it against the crowdsourced or the third-party data sources. So give us a true measure of how each of these data sources are performing. But we also wanted to develop the full model set using all permanent and short duration counts, which then gave us the ability to expand our modeling suite further. Another categorization that we did was to develop both the conventional count and the machine learning models. The conventional count models were Poisson models, and in machine learning, we tried different specifications, but ended up with the random forest model. Because we don't have too much time in order to go through all of these models, and there were over 100 of them. Details are all in the final report. I'm just going to focus on the conventional count models, but the learnings are very similar from all the different modeling exercises that we did. So across all the modeling forms, we added each data source systematically to try and test out the effect that it was having and introducing when it was being introduced into the model. And our dependent variable across all the modeling forms is AADBT, or annual average daily bicycle traffic. And so, okay, so let's take a look at the results. So this table here is our full year for permanent count model. And as you can see on the left, each of these are the models where there's just one data set added. And then the latter columns are when we add 2 or more of the data sets. And then the final model is where all the data sets are combined. So a couple of takeaways here that we noted. One, the data sources tested here appear to be complementary. That is, adding 2 or more together outperformed just adding one data source together. In most cases, the best model is where we had the static data plus Strava and Streetlight all added together. And another takeaway is the high errors that we are seeing at these low volume locations. One thing to note here is that even when you're off by a small count at the low volume locations, that can introduce large amounts of error. So for example, one of our locations, we were off by 10 cyclists in that, and the error increased by 83%. But that's something to remember. But then we are seeing these high errors at these low volume locations. Just some quick takeaways again. The combination of variables are doing a good job in performing ADBT. And we also did notice that despite the user bias in Strava, it did outperform Streetlight either on its own or in combination with the other static variables. One exception to the trends that we were seeing was in Dallas, where the combination of Strava and Streetlight nearly matched the combination of all 3 sources in the model. The next set of models is where we combine the permanent counts with the short duration counts. And this graph, I apologize, is a little busy, but I'll try to walk you through it. So here we are starting to see a couple of trends. We started, because of this expanded data set, we were able to estimate city-specific models. And you can start to seeing that the city-specific models error rate is much lower than the pooled models. So that was one of the takeaways. We also found, for example, in Boulder and Dallas, that the best performing model is not always the one which combined all the 3 data sources. Dallas, we saw that just the Strava and Streetlight model did quite well on its own without any adjustment. In Boulder, for example, we see that the Strava plus static model is doing better than when we add all 3 data sources together. We also, again, looked at volume bins and the error distribution across those bins. And again, we're seeing very similar trends. Error rates are very high at low volume locations, which leads us to probably an important takeaway that we need to start counting more at these low volume locations. We want to see these error rates drop. And I talked about this earlier. We wanted to see what happens if we estimate city-specific models and compare the error rates with the Oregon pooled and the all-city pool models. And we are seeing that the city-specific models do have lower error rates because these have parameters that are more tuned to the local context than the pooled and the all-city, the regional pooled and the all-city pool models. We do recognize that not all cities have the resources or the data to estimate city-specific models. And so if you're not able to do that, then the all-city pooled or even the regional pool models can give you some decent estimates of bicycling activity. So here are just the takeaways for posterity. Already gone through most of this, but another thing that we also wanted to mention was that when we are estimating these local models and or the pool models, we also did some tests to understand if we estimate a model in 1 year, does it transfer well to other years? And we found that while the model form transferred well, it is important to re-estimate the model parameters year to year, because we do note that the underlying data, the Strava and Streetlight user base is changing from year to year. And so, so we do recommend that even if you transfer the model forms, re-estimating those model coefficients year to year will help in reducing the error. And again, the low volume sites, you can estimate noisy estimates because we do not have enough counters there. But in the high volume sites, our predictions are pretty good. So one other thing that I wanted to touch on is this adjusting the Strava and Streetlight counts. So if we leave the Strava counts unadjusted, that's the blue line here, we estimate that there are about 13 cyclists for every one Strava count. But we really need to adjust it because the Strava data or the Streetlight data can represent different things at different locations. So for example, here, as we are moving away from the center of the city, we are seeing that the adjustment factor is smaller for Strava because presumably at these locations, which are farther out from the city center and which are more recreational sites, Strava is capturing a bit more of the users. But whereas at locations that are closer to the city, the Strava is capturing obviously the lesser amount of users or bicyclists that we are seeing. It's really important to adjust these counts. Then we started looking at what happens if we don't adjust Strava and Streetlight, right? What happens if we don't add the contextual data? And so our error rates really go up. So if we just use Strava only or Streetlight only, we can expect 40% more error than if we add the local contextual variables. Mike, am I close?
Yeah, maybe a couple minutes to wrap up.
Okay, so I will hurry up. Yeah, and I've already talked about this is we need to re-estimate the models and the model parameters to reduce our rates. And so in terms of conclusions and what our key takeaways are, as others have said this repeatedly, what the study has shown is that counts are really, really important for validating big data sources. They are our closest measure to ground truth. And so we definitely need to invest in counters, in permanent counts, in short duration counts, and getting those right. Accessing and standardizing count data was challenging. And so as much as possible, if we could invest in standardizing this, getting it from a central archive, that would be great. Another big challenge we found was this lack of variety in permanent count locations. This really limits our ability to expand to the network. And so we definitely need to cite our locations better and count in those low volume locations. In terms of modeling, we found that the data sources are complementary. They're all adding something to the model to reduce our error. Our local models perform better than pool models, and the machine learning models performed as well as the traditional count models, but our data set is small. The power of machine learning lies in big data, and we really do not have big data. And so, and because of the limited count locations that we have, and so we think that the machine learning approaches are likely to outperform with a larger data set. So in terms of our recommendations, we definitely are recommending to install more permanent counters. We need this on a wider variety of contexts. And as others have said, plan and budget for ongoing validation and maintenance. We did use short duration counts in our study, but we do recognize that this can introduce additional error. Standardize and automate your count data and storage with all the, that will help getting the data easier. And then finally, the data and modeling recommendations. This work showed a really promising direction for improving network-wide count estimation, but there is definitely more work to do in this area for sure. So in terms of expanding to the network, we took our best city specific model. This is an example for Portland. And we took the static plus travel model because it was, we did not have streetlight counts at all these locations. And then we expanded it to the network using both the count and the machine learning techniques, and then compared these estimates to the ones derived from the travel demand model. So quickly, other research that we have in progress, we've already talked about the push button data and trying to get counts from that, specifically pedestrian counts. We also want to have another project that is currently in progress, basically exploring the similar use of these crowdsourced data sources for pedestrian count estimations. So with that, just like to thank everybody for listening, and I'm happy to take questions. As mentioned, Joe and Kate are here too to help with the Q&A.
Great, thank you so much, Sirisha. We did get a question about someone working in a small city with no bike counters, asking where to start. Looks like a couple of folks are maybe going to address that, but Sirisha, I'm wondering if you can speak to kind of whether some of these data sources that you incorporated in your model would be a place to start for a city like that, or whether, you know, maybe going the permanent counter route to begin with would be more beneficial.
I'll start, and then maybe Joe, Kate, or Krista also jump in. I think that we have to start with the permanent count data, because we need those ground truth counts to help understand our big data sources. So, so I would start there, and then once we have that data flowing, then we can look at estimating models such as this. Joe or Kate or Krista, I don't know if you wanted to add anything.
It looks like Krista did add in the chat. Oh, yeah, go ahead, Krista.
I totally agree. Installing permanent counters is a great idea, and also reach out to other agencies. Often the Parks Department are already collecting data, and other agencies even within the same city don't even know. So you may actually have more data than you think. And then reach out to the nearby other cities or other counties or MPOs to see if they are collecting data so that you can share.
Thank you. Another question that we got from earlier that I want to circle back on, and Sarisha, maybe you can start, and I invite others to certainly chime in as well, because it's so maybe tangentially related to what you just presented on. But anytime we're talking about these large data sources, particularly involving people's travel habits, there issues of privacy come up. And so I'm curious, to what degree, maybe you could speak a little bit on what data you actually receive from these other sources, maybe if it's been anonymized, but also whether they're the Texas example we saw, and certainly Delaware Valley, many of these agencies are posting their information, making it publicly available. Are there any issues with relying on these emerging data sources and maybe kind of incorporating them into count data in terms of privacy that agencies should be thinking about?
I'm actually going to ask Joe. Joe, do you want to take this question since you work most closely with the Strava and Streetlight data?
Sure, I could speak to that a little bit, Mike. I mean, it is an important point because it's definitely on everyone's minds when you start using, especially this user-based data. I would say, one thing that we learned is that what was of most interest to our technical advisory committee and our pooled funders was that AADBT estimate, which, at that level of aggregation, there's very little, if any, privacy concerns. So we did, though, receive hourly data. Like Sarisha said, that hourly data from Strava was masked to some degree. So they do just kind of like a rounding up and down to the fives to help mask, especially those low volume locations. But again, the privacy risk is pretty limited since you're really just getting that count at some point along a person's trip. It's not tied to any sort of residential location or work location. So in that sense, I feel like this count data is, others might disagree, but to me, the risk is pretty minimal. And I think the aggregation level you need to do the modeling to support policy is pretty high level, which further kind of masks the user information. But the companies are certainly thinking about it, and the agencies and the users themselves. And I think we do have to keep in mind that data like Strava, the quality of that data is going to be impacted by how the users feel about their privacy. And so I think, we do have to approach it from that standpoint, that if users start logging trips less often, or fewer users are comfortable doing it, then this data quality could decline if we don't manage that carefully. So I'm glad you brought it up, because it's a good thing to keep in mind that we need to think about that from a PR perspective on our research and agency use of this data too. If anything else to add on that from any of the team or anyone else?
Great. Well, hearing none, yeah, I appreciate that response, Joe. Thank you. So, so I think we were probably about time to transition to our closeout. I want to really thank Sarisha and Joe and Kate and your research team for sharing your work with us, and certainly a topic that I think we're all going to kind of continue to track as it evolves. So before I hand it over to Andreas for some closing remarks, I just want to remind folks that we will be posting the slides, making those available on the event webpage, and I'll put that link in the chat one last time. And we should have those up by tomorrow, and you'll get an email when those are up. And then we'll also be posting the recording probably later in the week. With that, Andreas, I'm going to hand it back to you to close us out here in the last 10 minutes.
All right. Well, first off, a big thank you to everybody who's attended. Hopefully this was an informative workshop for y'all. And please join me in also a big thank you to all the presenters and the organizers. So great job, everybody. Really appreciate all the hard work. Putting something together like this takes a lot of work and effort and time. So very much thank everybody who participated. Just some from my notes, I just wanted to kind of go back and review some of the major themes that I heard throughout the workshop. This morning we heard from FHWA about the wide range of needs for active transportation count data and that they've presented a report to Congress that identified the need for the count data, but also that obtaining count data is one of the major challenges for the active transportation program in general. So we also heard that what gets counted gets managed and funded, which is important. And the importance of upgrading to automated counting to get those longer durations. We saw a couple of really neat applications of some of the new kind of trajectory data and path tracing data by mode that the new cameras can get you with the video detection, and how that helps understand travel behavior as well as volumes. And we heard about some of the key steps in developing a count program, and two critically important ones are the strategic planning and the site selection. So, and throughout the day, we heard that the count data is used beyond just transportation. So departments of health, parks and rec, other people are already collecting this data or are interested in collecting the data. And there were two instances that I heard of where departments of health actually funded, supported grants to help collect some of the count data. Then we got into some of the nuts and bolts. I presented an overall vision for the count program and that Caltrans is working on, and talked about some of the importance of the statistical design. Big data integration is really important and provides powerful new tools, but it doesn't replace the need for the count data. We need to focus on the permanent and continuous counters. They're really the key to understanding trends and variability, and developing extrapolation factors for the short duration counts and for calibrating the big data. Intersections are unique and should be treated differently. In terms of the count equipment, don't trust, verify, and know your vendor, and ask for third-party accuracy rates from the count equipment vendors. Signal detection is not the same as counting, and detection tends to overcount. If you're getting counts from detector signal detection, they tend to overcount, so be wary of that. Yeah, but there is some innovative work on the push buttons and correlating push button activations to counts. We heard a lot about the statistical difficulties in taking information at one place and estimating information at another place, and bringing in, starting to consider adding randomized counts as part of the count program. And Berkeley will be, Caltrans is collaborating with Berkeley to really investigate more of how we approach what statistical methods should we bring into the design of the network. The count duration matters, and short duration counts can miss a lot. So validation, quality control, documentation are really important. And the Texas database was a great example of some of the tools that you can incorporate, both for the visualization and understanding, but also on the data validation and side, and making that data shareable. We also heard from a couple of MPOs on their experiences and lessons learned, and in the terms in the data fusion, really looking at the best performance is when you try to integrate your count data with other sources of data, such as the big data and the mobility as a service provider data. Need to look at error across your different sites, and error rates tend to be higher at your low volume sites. So be sure that you're counting at your low volume sites as well. And your models need to be calibrated annually to keep pace with changes in travel patterns and third-party data algorithms. Some common challenges and lessons learned from across the different presentations is, some other agencies are likely already collecting the data. So get out there and understand who's already collecting it, start an inventory, start with the survey. That was one of the steps in starting the count program. The demand for count data is rapidly growing, and the technology is changing both on the count side and on the third-party data side. You need to focus on the count station network design and integration. Figuring out where and how many stations you need and where they're going to be located is really important. The automation of the counts, the real-time data transmission and integration with big data kept coming up. It's IT intensive, all of this stuff with the databases and the various technologies. So be sure you're partnering with your IT department and familiarizing yourself with the IT requirements. Collaboration is key. I think we heard that across every presentation. You need to ensure that your counting efforts are equitable and that you're considering all populations and travelers. You need to provide the resources for the staffing and ongoing validation and maintenance for the count program to be successful. And it's important to make your data shareable. And that means having good metadata on your count stations and methods, standardized data and formats, and protocols for collecting the data, validating the data, documenting the data validation, quality control, and then a database to house it and then make that easily accessible. Another effort with Caltrans is partnering with Skag and UC Berkeley to develop a statewide database, somewhat similar to what Texas has, and have some of those tools available for the folks that will be collecting the data and have the tools to quality control and validate and share that data. And then lastly, investing in the standardizing of the count data, the count technologies, and the data repositories for ease of access. So those were kind of the main themes that I heard throughout the day. I do want to take a minute to encourage everybody to fill out the exit survey from today's workshop. It will be open for a week, so through next Monday. That will help us understand how to improve future workshops, but also there are some important questions in there to get some feedback from you, the audience, to understand who in California might be already collecting this data, so that we can start in on our efforts to try to create an inventory to understand where existing count stations even are, and to target directed outreach on some of our survey efforts as well. So please fill out that exit survey. That's really important. That's all I had. If you have any more questions for the statewide effort, network design effort, please contact me. My information's on the website there and in my presentation. And that's it for me. Mike, do you have any closing comments?
No. Thanks everyone for participating.
Okay. Well, thanks again, everybody.